So we continue with the periodic table, and now, so we already understood what are the different periods and the different groups, and now we see some reference elements of the different periods and the groups. So we are going to have the properties of the different groups. So first thing is, special references are going to be seen over here for alkali metals, alkali earth metals, halogens, and zero group elements. So these are the four things which you are going to learn, the periods which you are going to be, the groups which you are going to learn even for the 10th standard. So you need not learn the बीच में का जो transition है उसका ज़रूरत नहीं है, but group 1, group 2, group 17 and group 18 are the ones which you need to study. So let's see one by one. The alkali metals first. They are present in group 1, that is 1A of the modern periodic table. The elements present are light metal from lithium to francium. Group 1 elements have 1 valence electrons in outermost shell and hence are univalent. Alkali metals are strong reducing agents. They are electron donors and have 1 valence electrons in the outermost shell, which can be easily removed. So the main thing over here is, of course, valency तो हम लोग को मालूम था कि they are group 1, so valency will be 1, all of them will be univalent because उसका electronic configuration क्या है 1, 2,1, 2,8,1, 2,8,8,1, तो पूरा उसी तरह से है, तो you know that the valence electrons are univalent. But what does it signify as a chemical properties is, firstly is that they are strong reducing agents. Okay, they are strong reducing agents. Mean what? They can reduce certain things. That means they are the one which can easily get oxidized. Okay, so that's why they are reducing. So they are easily get oxidized. That's right. Reducing agents get oxidized very easily. That means they are able to lose their electrons more easily. So first thing is that they are strong reducing agents. They are electron donors and have 1 valence electrons in the outermost shell. Yes, univalent है इसलिए they are having 1 electron in the outermost shell. So definitely they are going to leave that electron to somebody, give it to somebody else. So they are electron donors, and which can easily be removed. Yes, of course, because their ionization potential, the weight is less, and hence they can easily give away that electron to some another element. The elements are highly reactive electropositive metals which are soft and can be cut by a knife. They are good conductors of heat and electricity. So now we see the property wise, yes, they are highly reactive. Okay, they are very reactive in nature. Why? Because एक electron तो देना बहुत easy है उसके लिए, and it can form into a cation and then it can react with anything. So that's why it is going to be highly reactive. Physical property wise, they are soft. They are so soft that they can be cut by a knife. Yes, potassium, sodium, you can cut it by knife. They are so soft. And they are good conductors of heat and electricity. They form electrovalent compounds with non-metals, that is KCl, NaBr, etc. So all these, because they are going to form, they are going to lose the electrons and they are going to become positively charged ions, that is they are going to become cations. So easily they can form the covalent compound with an cation, so anion, and that's why it is going to form a maximum. These ones will form electrovalent compounds. They can form only electrovalent compounds. They cannot form covalent at all because they cannot share electrons. The next are alkali earth metals, very similar to the alkali metals. Okay, so they are present in group 2, group 2A of the modern periodic table. The elements are light metals that are from beryllium to radium. Group 2 elements have 2 valence electrons in the outermost shell and hence are divalent. Of course, it is 2,8,1, 2,8,8,2. So automatically, 2,8,2 or 2,8,8,2. So automatically we know that the valence electrons are 2, so it is divalent. Alkali earth metals have properties similar to alkali metals but are slightly less reactive than alkali metals. So yeah, the properties are quite similar to the alkali metals, but they are, because वो यहाँ पे एक वैलेंसी था, यहाँ पे 2 वैलेंसी है, तो थोड़ा बहुत डिफरेंस आएगा, but that's the reason they are slightly less reactive than the alkali metals. So alkali earth metals have similar properties to the alkali metals, but they have got lesser reactivity. The fourth group we are talking about is the halogens. Group number 17. They are present in group 17, that is 7a of the modern periodic table. The elements are non-metals from fluorine to iodine. Acetane, the nature is still under research. Group 17 elements have 7 valence electrons in outermost shell and hence are univalent. So here we see that the valency will be 2,7, 2,8,7, 2,8,8,7. So automatically there will be 7 valence electrons. That means it requires 1 electron to complete its outermost orbit. So it requires, so it is electronegative in nature, and at the same time, but still the valency is univalent. Why? Because it requires only 1 electron. So that's why they are univalent but in a negative form. Group 17 elements have 7 valence electrons on the outermost shell and hence they are univalent. While halogens are strong oxidizing agents. So because they can accept electrons, they are going to oxidize, they are oxidizing agents. So they are going to get reduced, and accordingly they are oxidizing agents. They are going to get reduced means they are going to accept electron. Gain of electron is reduction and loss of electron is oxidation. We learn this thing in detail when we are doing the hydrogen chapter. So what is oxidation and reduction? But yeah, mainly just understand one thing, that whenever any element loses electron, it gets oxidized, and when it is going to gain electron, it is going to get reduced. And oxidizing, one which gets oxidized is a good reducing agent, and one which is getting reduced is a good oxidizing agent. तो उल्टा है सर. तो इसीलिए you find over here that the metals like sodium and all, they were good reducing agents. Whereas over here, because they are getting oxidized, that means they are going to lose electrons. Whereas the one which over here, we are going to get reduced because they are going good oxidizing agent, against they are going to add electrons to itself. So halogens are strong oxidizing agents. They are electrons acceptors since they have 7 valence electrons in the outermost shell, which can easily accept 1. The elements are highly reactive. Of course, it can get 1 electron very easily, that's why they are highly reactive. Electronegative non-metals. They are highly reactive, but they are electronegative. They are not electropositive. Electropositive कब होते हैं? जब वो electrons देते हैं. Here they are electronegative, means they are going to accept electrons. So they are electronegative and they are non-metals. They are bad or non-conductors of heat and electricity. They form, in fact, that also can be known. Why it is the non-conductor? Because they don't have free electrons. Okay, they don't have free electrons. That's why they are non-conductors of heat and electricity. They form covalent compound with non-metals, that is HCl, PbCl3. So yes, these are the ones which can form covalent compounds with another non-metals, and of course it can form electrovalent compounds with metals. Halogens means salt producers. Halogen. Hel is salt, gen is generator, so that's producer, so that is why halogen. Since they react with metals to form salts, so Na plus Cl is NaCl. The most reactive halogen is fluorine and the most abundant is chlorine. Fluorine may be added to the water supply since it prevents tooth decay. Chlorine to swimming pool to kill germs, and iodine is used in iodized salts. So you can see that halogens are very much used in our regular life, because you can see that fluorine is added in water for helping in the preventing tooth decay, and chlorine is used in the swimming pools because it can kill germs. Iodine is a part of the iodized salts what we are eating, because thyroxine produce करने में मदद करता है, तो thyroid gland को मदद करता है iodine. So that's the uses of halogen. So atomicity, we know that they are diatomic. All the halogens are diatomic. You will always, whenever you write chlorine in a symbolic form, you will write Cl2. Iodine will be I2, Br will be Br2. Okay, so that is diatomic in nature. Fluorine F2, Cl2, Br2, I2. State will be fluorine and chlorine are gaseous, but bromine is liquid at room temperature and iodine is solid. So that's the main thing, that iodine is a solid at room temperature, bromine is liquid at room temperature, fluorine and chlorine are gaseous. The next type of elements or the group what we are learning is group 18 or group 0, which is the noble gases. They are present in group 18 or 0 of the modern periodic table. The elements are non-metals from helium to radon. Group 18 elements have 8 electrons, valence electrons in the outermost shell, except helium, which has got 2. Valency or combining capacity of noble gas is 0. They have a stable electronic configuration. So you can see over here that each and every element present in the group 18 has got valency 0 because it's either duplet in case of helium or octet in case of the others is complete. So they do not require any electrons for sharing or giving or taking for completing that outermost orbit, because it's already complete, and that's why they are inert in nature. So that is having a stable electronic configuration. Noble gases do not react with other elements and are therefore inert or unreactive. They are all monoatomic gases. So the valency wise, because they are 0, that's why they are monoatomic. That means they will not be forming two atoms. जब भी उसके molecules बनते हैं, तो one single atom itself acts as a molecule. They are freely available in free state, in atomic state itself. So that's why they are monoatomic gases. Now we see the study of the features of the matter periodic table. So features wise, how does the matter periodic table function? Features of the modern periodic table, long form of periodic table. First one, till date about 118 elements have been discovered, and the study of the properties of each element is a difficult and tedious process. The periodic table containing elements methodically grouped make the study simpler and systematic. So that's the main purpose of the periodic table. What's the purpose of periodic table? That if I have got the elements grouped in a particular kind of a grouping, then if I am studying one particular group, automatically I need not study the other elements in the group. I just need to have the salient features of that group, of that particular element seen, जो addition में है वो. Otherwise you find that they are going to all behave in a similar manner. So that's the main criteria of having a periodic table, that the periodic table containing elements methodically grouped is going to make the study simpler and systematic. The table is based on the classification of elements using the fundamental property of atomic number, thereby arranging all elements according to their increasing atomic numbers. So yes, we have known that all the elements are placed in the increasing order of the atomic numbers. It correlates the position of the element. So now very important here is that if I know the atomic number, like if we talk about the first 20 elements, if I just say the atomic number of something is, let's say, 15. So if I know that atomic number is 15, so I know that the protons are 15, electrons are 15 and neutrons are 15. मुझे और किसी से मतलब नहीं है, इससे ही मतलब है. तो ये जो मतलब इससे क्या होगा? It will be, I know that it is 2, 8, 5. Now what is the thing? What is going to help me over here is that 1, 2, 3. That means it is in the third period. Okay, it is in period number 3, and this is 5 over here. That means it is going to tell me that it is in the 15th group. So group number 15, period number 3 can be identified using this particular. So if I know the atomic number, I can even tell where exactly in the periodic table. Of course, it should be the representative elements. So these representative elements, the first 20 elements, you can easily make it this way. Okay, first 20 elements, by just knowing the atomic number, we can find out which period and which group does they lie. So because electronic configuration refers to the distribution of electrons in the different shells. The K shell has got maximum 2 electrons, L has 8, M has 18. So the first period has elements only H and He, filling up 1 or 2 electrons in their K shell. So because K shell में कितने electrons है? सिर्फ 2 electrons हो सकते हैं. Therefore, how many elements can be there in the first period? Only 2. The first period can have only 2 elements because it has got only 2 electrons possible to be there in the first orbit. The second period has got 8 elements, that is Li to Ne, filling up 8 electrons in the shells L to L shell. And third period has got Na to Ar, filling up 8 electrons in the field M shell. Because the last orbit cannot have more than 8 electrons. That's why M shell पे वो अटक जाता है. Thus, the complete periodic table of element is easily and systematically built up. Easy segregation of elements, groups, elements with similar outer electronic configuration, same valence electrons are placed in one group, vertical columns, and they have the same valency. All these elements in the group have similar or graded properties. Thus, if the property of one member of the group is known, the property of other members of the group could be correlated. So this is the advantage. And if I know the elements of first का अगर मुझे data मालूम है, first 3 का मुझे मालूम है, तो fourth 5th मेरे को पढ़ने का जरूरत नहीं है. Automatically I can determine the properties of those. Periods wise, on moving from left to right in a period, there is a gradual change in the periodicity of the elements with increase in the atomic number. So the properties tend to repeat themselves at regular intervals. Yes, because first के बाद 9th फिर से आएगा साथ में. The properties which reappear at regular intervals are called periodic properties. Separates elements with respect to nature of elements. So another thing what the periodic table tell you is that, okay, to the left of the periodic table all the ones are metals. To the right of the periodic table all are non-metals. And we can segregate them to be metals and non-metals very easily. So metals including alkali metals and alkali earth metals are in the extreme left of the periodic table, and transition elements, which are all metals, are placed in the center. Non-metals are placed to the upper right corner of the modern periodic table. Noble gases are placed in the extreme right of the periodic table. Thus the periodic table makes arrangement for element of elements in easy and simple to reproduce. Now, in spite of all these features, there is a drawback, and that is the drawback of the position of hydrogen. In spite of the superiority of the long form of the periodic table, it has a few defects, which includes position of hydrogen, which can be placed at group 1 or group 17, and the position of lanthanides and actinides. See, lanthanides and actinides are placed in the group period number 6 and 7 as a separate group altogether. So that's why it is separate. So the position of lanthanides and actinides which do not have any individual place in the table. So there is no individual place in the table. They have got a separate kind of a section at the bottom of the periodic table for lanthanides and actinides. So the next is the position of the elements. That is, elements are placed in periodic table on the basis of electronic configuration. All elements in the periodic period have the same number of electron shells, and in a group have the same number of valence electrons. So if you see hydrogen, it is atomic number 1, so it is valency is 1, so it is assigned group number 1. Okay, so alkali metals, halogens, other elements in the group with same valence electrons are alkali metals and halogens. So that's why we see that hydrogen is compared to not only the alkali metals but also the halogen. So both जगह पे आ सकता है, because hydrogen can accept one electron and completely duplate, or it can give away its electron and become 0. So वो दोनों possibility उसके पास है. That's why it is going, or even sharing is possible for it. So that's why it is going to have valency as +1 or -1. Carbon is 6, which is 2,4, which is 4. That's why it is in group number 14 or 4A. So other in the same are silicon, germanium, Sn and Pv, tin and Pv. Nitrogen is 7, which is 2,5, so 15. And oxygen is 8, which is 2,6. And then sulfur is 2,8,6 again, that's 16th again. And chlorine will be 17, will be 2,7, 8,7, which is fluorine, bromine, iodine, and acetylene. So group characteristics or properties of the elements in a group. So position पहले देख लिया, not important at all. There is nothing which is too much important, which कुछ पूछने के लिए, question पूछने के लिए कुछ ये नहीं है. There is nothing important over there. Group characteristic properties of elements. So chemical properties depend on the number of electrons on an atom can gain, lose, or share. All elements in the group have the same number of valence electrons, hence elements in the group have similar or graded properties. So we very well know that depending on its valency, either it is going to give away its electron or accept electrons or share electrons. because if the number of valence electrons are the same, then the way it is going to behave with other elements to form into compounds is also going to be the same. That's why we find that because they are of the same similar electronic configuration, that's why they will be having same kind of chemical properties. So all elements in the group have the same number of valence electrons, hence elements in the group have similar or graded properties. Some general group characteristics are allotrophy, ability of element to exist in more than one form, exhibited by elements in group 14 except like lead, and group 15 except Bi, and group 16. Electronegativity, tendency of an atom to attract electrons towards itself when combined in an atom. So this is another kind of important characteristic that is called electronegativity. Now electronegativity means if there are sharing of electrons taking place, तो sharing कभी भी न्यूट्रली नहीं होता है, दोनों ने सेम जगह पे शेयर किया ऐसा नहीं होता है, okay, not necessarily. So it will depend upon the electronegativity of the substance. Some elements will be attracting the electrons more towards themselves and some may be attracting less towards themselves. So one which is attracting more, it will have more electronegativity. We are going to learn this in the 10th standard in detail, but here you can just learn it as a definition. The tendency of an atom to attract electrons towards itself when combined in an atom is electronegativity. The next is non-metals. Non-metals are basically gain of electrons or are electronegative in nature. Metals will be, of course, they are losing electrons and electropositive in nature. Electronegativity, when I talk about electronegativity, the electronegativity will increase from left to right in a periodic table. So increases across a period and decreases down the group. And non-metallic nature increases across the period and decreases down the group. So that is what they are shown here in the figure, that when electronegativity, if I go down, it decreases, and so that's why C, most electronegative are C, N, O and F, and least one are Pb, Bi, Po, At. Non-metallic characters decreases, so C, A and F are most non-metallic, non-metallic, whereas Pb, Pi, Po are metallic. And then we have the summary, which is the same thing. So yeah, that's the end of the chapter. Okay, so this is the end of the chapter. Now the last part of the chapter, which was over here. Now the thing which is as such, the whole thing what you are seeing over here, you are going to be in the 10th standard, so you need not worry about this part, but still you can have a look at this part, that is metallic characteristics. So we can just note it down this way, that when you are going across the period, so we have got over here certain periodic properties which you can learn through. Is first one is, as per what they are given here, is electronegativity. So when I am going from left to right, it is increasing, and from top to bottom it is decreasing. The next could be metallic character. So metallic character will be such that from left to right it is going to decrease, and from top to bottom it is going to increase. Okay, in the increasing order, right? Similarly, non-metal क्या होगा? It will be opposite of this thing. So from left to right it is going to increase, and from top to bottom it is going to decrease. We can also see, okay, that's, I think that is sufficient for the 9th standard. So metal, non-metals, and metallic character and electronegativity. So this is the periodicity, or you can say the periodic property. Okay, what is the kind of transition when you go from left to right? What will happen to the electronegativity? So if I am going in a particular period, when I go from period in a one period from left to right, then what will happen? यहाँ पे इसका increasing order of electronegativity यानी इसका सबसे कम, फिर थोड़ा ज़्यादा, थोड़ा ज़्यादा, थोड़ा ज़्यादा, थोड़ा. So chlorine will have maximum electronegativity. The same way, if I going from top to bottom, then if I go from lithium, potassium, sodium, potassium, etc., so you say that cesium will have the maximum number, the least amount of electronegativity. Okay, so this is how we are going to see the trends. So the trends will be down the group. This is down the group, and this is across the period. This is called as This is across period, and this is down the group. Down group. Okay, this is down the group and this is across the period. Okay, so quite an easy chapter. Mainly what you will be required to learn is about the Dobinus triads, the Newland's octave, the Mendeleev's drawbacks and the advantages, and then finally the Moseley's period. And then you need to know about the periodic table as such, that what are groups, what are periods, and if I give you a atomic number, then tell me what is the period and what is the period number and the group number of that particular atom. So such things are important, but overall a very easy chapter. Okay, so this is the end of the chapter periodic table. Okay, thank you.